Today we're looking at two topics. We're looking at midpoint again. We saw that a little bit yesterday, but we're going to use it in a slightly different manner. And then the second topic down there, it has to do with circles and the equation of a circle, which should be a review. You saw that material back in your geometry class, but we're covering it again today. So let's start off with our midpoint. There's the traditional midpoint formula. This is the same formula, but it's written in a slightly different way. What we're doing is we're taking the information out of the ordered pair and we're grouping it so that you have one calculation for the x's and one for the y's. The concept is if we do this work here, then the answer is what we get. So we're just putting all of the information with the x's together, and we're putting all of the information with the y's together as well. So it looks something like that. This will be super helpful for an example like number 2, so we'll get to that in a moment. Here's our midpoint formula in the more traditional sense with example 1, but it's a little bit of a story problem here, so it's not represented in quite the same way. Let's talk about this. So here we have the same information that we saw in yesterday's notes from Starbucks. So in 2016 they made this money, and in 2018 they made that much money as well. All right, so yesterday when we were taking a look at that same setup, the question was slightly different. The question there was calculate the percent change using the rate of change. And that's not the same as the that's not the same as the midpoint formula, because here we're only using the dollar values. We did not really use the year 2016 or the 2018, except to just determine which was the more recent data, which was the more old data. When we're using the midpoint formula, we're going to be using both year and dollar amount because we want both an x-coordinate and a y-coordinate. So instead of thinking of this as a traditional x and y, think of it just as an ordered pair where you have year, comma, dollar amount. So that way we can generate two ordered pairs. In the year 2016, we had the amount of 21.316, and that's in billions. And then in 2018, we have 24.72. All right, so now that you have two ordered pairs, think of this as your x-coordinate, which is the year, and your y-coordinate, which is the dollar amount, and we can set this up. So I'm using the traditional midpoint formula here, which says add up your x-coordinates, so 2016 plus 2018, all divided by 2, and then add up the y-coordinates, which are your dollar amounts, and divide by 2 as well. So using our calculator to help us out, notice we get a year of 2017. And that was the question. Estimate the revenue, well, we'll calculate the revenue for the year 2017. So because 2017 was right in the middle between 2016 and 2018, that's how we knew to select the midpoint formula. I should have mentioned that up front. But that's how we knew to select the midpoint formula, because that is recognizably in the middle between 2016 and 2018, and sure enough, that's the result we got. Now for the dollar amounts, we end up with a value of, I think, 23.018. Let's just finish that off by answering the question, what was the revenue? The revenue was, so let's use the units, so dollar sign, 23.018, and that's in billions. So just kind of add on those units there. All right, so that was the traditional midpoint formula. Now let's take a look at the one that's not quite so traditional in example number 2. And the reason why this works a lot better for example number 2 is because notice what they give us. They give us one endpoint at A, and they give us the midpoint. So normally we're trying to calculate the midpoint, but if you already have the midpoint, we want to work the problem backwards to find what's missing. What's missing is the second endpoint. It can help to draw a diagram. You don't have to draw a diagram, but I recommend it to wrap your head around what we're about to do here. So we know that A is at negative 511. So again, I'm not plotting points. I'm just representing what we know and what we don't know in this illustration. So we know point A, but we don't know point B. So it gets both variables, both x and y. We know the midpoint, and that's at 2, 4. So what we're doing is using this method where we calculate with just the x's and just the y's, instead of bunching it up as an ordered pair. So this says add up your x-coordinates on the ends, right? It's always the x-coordinates on the ends, and the result is the x-coordinate in the middle. That's what this is saying right here. This is the x-coordinate from the middle. So the x-coordinates on my endpoints are -5 and x. That's what we have to add together. Over 2, and then that equals the x-coordinate in the middle, which is regular 2. So put that as 2 over 1. That way we have a proportion, and now you can easily cross multiply. So -5 plus x times the 1, and then 2 times 2. Let's add 5 to both sides, and we get 9. So now we know that this endpoint at B has an x-coordinate of 9. So for the y-coordinates, we're going to repeat the same process. Add up the y-coordinates on the ends. So we have an 11, and we have a y. So 11 plus y all over 2 equals the y-coordinate in the middle. So that's what that is saying, the y-coordinate in the middle, which is the 4. Put that as 4 over 1, so you can cross multiply. So 11 plus y equals 8. Subtract the 11, and we get -3. So notice that when we're finishing it up, we return it back into an ordered pair, but that's how we can do the calculations for the missing endpoint. So that's topic number 1. Topic number 2 is talking about the circles, and here's the standard form. We're using a lot of letters here. Let's see what's going on. So the H and the K, you see it in the picture, that's your center. H and K are at the back of each pair of grouping symbols. So at the front is the X and the Y. That represents a solution point. So it's not really spelled out here, but let's add that information. X, comma, Y is a solution point. And what that means is it represents any point on the circumference of that circle. So you could have lots of solution points, but you have only one center and one unique radius. So there's your radius of R. So let's start off by sketching. What we're doing is recognizing where our center is and what the radius is. So we want to find the H and the K because H and K represents the center. So this is where you look for the H, this is where you look for the K, but you can't use that number of 7 because we want the opposite of this number. That minus sign that you see right there means the opposite of that number. So I don't want 7, I want the opposite of 7. Here you see the K, it looks like a Y minus 1, but again, you don't want that number, you want the opposite of that number in that spot. So the opposite of a -1 is in fact +1. So the mental shortcut is you're just changing the signs. Whenever you take a number like this out of grouping symbols, you always change the signs. Now the R squared is the 4, right? Because the R squared is on the right-hand side of the equation. So 4 is not the radius is 2. So in graphing this, let's start with the center at -7, 1. All right, so there we are in quadrant 2. And then what we're going to do is, before we draw freehand that circle, give ourselves some guide points. So with a radius of 2, I know that my circle will be found to pass through this point, which is 2 units above the center, this point, which is 2 below the center, this, which is 2 to the right of the center, as well as this point, which is 2 to the left of the center. So that's my radius of 2, up and down, right and left. And then just use those as guide points to freehand your circle, and it looks pretty good for a freehanded circle. Here's one more. Again, this is your H. And notice we don't really have a K right there, so the K is going to be a 0. So in identifying the center, you want the opposite of -5, so you're thinking +5. There is no value of K. The R squared is 20. And in this case, I want a decimal value so I can figure out how to plot that distance. So I'm using my calculator here, and it's rounding to about 4.5 with the scale that I've got here. So starting with the center at 50, and then finding a radius of 4.5 above and below, and to the right and to the left. And those, again, just give you some guide points so that you can draw your circle through them without making it look too lopsided. It's pretty good. So on the next page, we're looking at now building the equation of a circle given the center and the radius. So let's look at the top of the next page. This is example 4. We'll look at both A, B, and C all together. So here we have the center. So that's provided to us. That's the H and the K. And of course the radius is the R. That's the 3. So here's the formula again, just for quick reference. X minus H quantity squared plus Y minus K quantity squared equals the radius squared. So in place of H, I'll drop in the 0. In place of K, I'll drop in the negative 2. In place of the radius, I'll drop in the 3, and it looks like this. So X minus 0 quantity squared plus Y minus. So there's the template, Y minus. The value of K is a negative 2. So notice our signs will change here in a moment. And then 3 squared. So when you're subtracting a negative, that turns into adding a positive. And so when we clean it up, we have an X squared. We have a Y plus 2. And that's why it looks like the signs change, right? So when the K is a negative 2, and you plug it back in the grouping symbol, you can do that mental trick to just change the sign so it looks like a Y plus 2. And then that equals 9. So don't leave it as a 3 squared. Turn it into a 9. So these next two are different variations of that when they do or don't give us certain information. So in part A, they gave us everything we needed. In part B, we only have some of the information that we need. We have our center, so again, that's our H and K. But notice they don't give us a radius. They give us a solution point instead. And on the previous page, we made a note that that is the X and the Y. So they're giving us these 4 numbers. Let's plug them in and then solve for the radius. All right, so it looks like this. I need my X, which is a negative 1, and then we're going to subtract the H. The H is 3, all of that squared, plus. Now we need the Y. The Y is a 1, and then subtract the K. The K is a negative 2. All of that is being squared, and that equals the radius squared. So again, notice subtracting a negative is adding a positive. So here you have negative 1 minus 3 is a negative 4. We'll square that in a moment. Here you have a 3 that we'll have to square. Remember, when you square a value, it always becomes positive. That's a positive 16 and a positive 9, which adds up to a positive 25. Now, we could go a further step and find the radius, but I don't really have to because the formula says I need an R squared. And look, I have an R squared. So a little bit of a shortcut. We can stop right there. Now we have our center, we have our R squared. Let's plug in what we have. So X minus the value of H, which is 3, because we always need a center and a radius, quantity squared, plus, and then Y minus the K. Now the K is a negative 2, so change that sign in your head to a positive 2, quantity squared, equals the radius squared, and there it is. So this is a little bit of a shortcut. We just take the R squared and put it right there. So in other words, I didn't actually figure out the radius. I mean, we know the radius is 5 when you take the square root of both sides. But if I had a radius of 5 and I plugged 5 back in, well, I would just have to square it all over again, and 5 squared gives me the 25, right? So I'm just saving myself a little bit of back and forth by stopping at the R squared. So we're going to finish off with this example, and this is the one that causes the most trouble because we have to solve this in a very particular order. If we reverse the order, it won't work out for us. They're not giving us a center, and they're not giving us a radius. They're giving us the endpoints of a diameter. So again, it can be super helpful to draw a diagram to explain what we have here. I'm not plotting points. I'm just labeling an illustration. There's my diameter. One of those endpoints is at negative 1 comma negative 4, and the other one is at 3, negative 2. So where would we expect to find the center? Right in the middle. So step number 1 is to find the center. And because it's in the middle, we want the midpoint formula. So we use those endpoints of that segment. Here's the traditional midpoint formula. Add up your x coordinates, divide by 2, add up your y coordinates, divide by 2. So that will simplify. So I'm jumping ahead to the final answer. You have a 1 and a negative 3. So let me put that to my diagram. There's my center at 1 comma negative 3. Now we need the radius. So if I want the radius, I could use these 2 points, the center and the endpoint on the right-hand side. But this is also a radius, so I could use those 2 points if I chose. I could use the center and the endpoint on the left. Doesn't matter which one. I'll use these 2 points so you can see what I'm setting up here. So this is now the second step. And this step is exactly what we did in the previous example where we had a center and we had a solution point. That's what I have here. I've got a center and I've got a solution point, so we're going to work to find the r squared. So I'm not just finding the radius, I'm going to find the r squared, so I can take that number and plug it into the equation for the r squared. Let me label. This is my this is my center, so that's my h and my k. This is my solution point, so that's my x and my y. That will just help me keep track of what numbers I'm plugging in. So we have an x minus h. So x is 3 minus the h of 1, quantity squared, plus the y is negative 2 minus the k, which is a negative 3, quantity squared, and that will equal the radius squared. Again, here we're subtracting a negative. That'll turn into adding a positive. So 3 minus 1 is 2. That will square. Negative 2 plus 3 is 1. That we will square. So we have a 4 plus 1, which turns into a 5. So again, notice I'm stopping here with the r squared. I'm not taking the square root of both sides because our shortcut then is to take that 5 and plug it in where we need the r squared in the formula. So we end up with a final answer of x minus the value of h, so x minus 1, all that squared, plus the y plus 3, quantity squared, equals 5. That's my radius squared. So there's the final answer. That's the equation of that circle. Now, what you see down here in the next example, this is another type of equation. Our book calls it the general form of a circle, which we're actually going to cover in our chapter on conic sections. So for now, we'll just skip this. We're good with this set of information up through example 4.